magnetic induction at center of current loop. This is a current loop. So current is in anti-clockwise direction and current is I. This is center. We have to find a magnetic flux density, magnetic field, magnetic induction at this point. We at center, magnetic induction at center of current loop. So this is what radius. Let A, radius of current loop, I, current, P is center, as well as observation point. By applying Biot-Savart Law, so we have to cut a current element. O is its center, direction of current, tangent ड्रा करिए यहाँ ऊपर. This is direction. So this will be theta. OP makes with the direction of current. Cut DL as shown. O is its center. Theta angle which OP makes with the direction of current. Now think of Biot-Savart Law. What is theta there? Angle which OP makes with direction of current. Now apply Biot-Savart Law. Magnetic induction at P due to DL, that is dB KIDL sin theta by R square. Here it is a square. Why? A distance. This is A. This is what Biot-Savart Law. Here theta 90. So dB becomes KIDL sin 90 by A square, or dB KIDL A square. What we have done? We have applied Biot-Savart Law. Now magnetic induction. Due to current loop, that is B, K common, I common, A square common, DL. That is DB. Sorry, it is B. Integrate. BKI A square L. L means total length. BKI A L total length. It is 2 pi A or B K I. This was A square. A square 2 pi A 2 A with this A or B is mu naught I 2 A. Direction out. राइट हैंड थंब रूल, ये यहाँ पर बाहर हैं फिंगर्स, आउटसाइड. बी म्यू नॉट एन आई टू ए. This is third, this is fourth. N number of turns. B mu naught n I vector A to A square. वेक्टर ए बाई यूनिट वेक्टर से किया हमने. तो दिस इज मैग्नेटिक इंडक्शन एट सेंटर ऑफ करंट लूप. Magnetic induction at any point on axis of current loop. Now this is the question. Magnetic induction at any point, and the point is where on axis of a current loop. So this is a current loop. This is current in anti-clockwise direction. This is center of current loop, and this is axis. This is axis. Marker is axis. The current loop is on board. This is axis. This is observation point here, and OP is X. This is what? Radius. current, A radius of current loop, O is its center, P is observation point on axis, and OP is X. How to solve this? We have to apply Biot-Savart Law. For that, we have to cut a current loop. This M is center, this is what current. Cut DL, M as its center. This is a P, this is P. ये ज्वाइन करो ये. Say it is R. ये ज्वाइन किया हमने ये. तो this angle theta. सीधी look ये है, ये नहीं है, ये है P ये. तो ये 90 होगा. यह दिख नहीं रहा 90 है. ये है अंदर ये. Now magnetic induction at P due to DL that is dB KIDL sin theta by R square. The distance, let this is small r square. What is this? Biot-Savart Law. And this is the direction. This should be perpendicular to this. Now MP and this I, they are perpendicular. This is MP. MP and I perpendicular. इस पर perpendicular ड्रा करा है तो DB will be perpendicular to I. Let this angle is alpha. Then this will be what? Alpha. And it is dB cos alpha. This is what? dB sin alpha. Similarly, if there is a point here, so this will be what? dB. Again it is alpha. It is dB cos alpha. And it is what? dB sin alpha. Now this dB is resolved as this. Sin towards alpha it is cos. बिल्कुल अपोजिट में लिया हमने दूसरा. Here theta is 0. So dB KIDL by R square. Hence, magnetic induction due to current loop that is B. Due to this is ये cancel, ये resolved, खत्म, equal and opposite खत्म. For every dl there is what? db sin alpha, db sin alpha, db sin alpha. So total will be integration of db sin alpha. For each dl there is what? ये यहाँ है, ये है OP, ये OP, ये. तो इधर db sin alpha, db sin alpha, और ये अल्फा भी कांस्टेंट है. यहाँ ज्वाइन करके देखो, ये p है, दिस इज p, ज्वाइन करो कहीं भी, अल्फा इज ऑल्सो कांस्टेंट. तो इंटीग्रेट दिस, तो db KIDL R square sin alpha, K constant, I constant, sin alpha constant, R square constant, DL KI sin alpha R square DL L. L means total length of current loop. The radius is A, so it is 2 pi A. This is R square. K mu naught 4 pi I sin alpha. A right angle triangle, sin alpha A by R square 2 pi A. B. It is mu naught I A square. This 2 pi with 4 pi to R cube. This is third. See the figure. R square was A square plus X square. Cube. So 3 by 2. 3 by 2. Two goes with R cube will be this. So B is mu naught I A square 2 A square plus X square 3 by 2. Fourth, B mu naught I mu naught and I A square 2 A square plus X square 3 by 2. And direction, see figure, along OP और अप्लाई राइट हैंड थंब रूल। तो कहाँ होगी उसको दिए था बाहर, तो along OP। स्पेशल केस at center, here x is what? 0. Putting in this equation, fifth, b mu naught n I a square 2 a square 0 3 by 2, it comes out to be a cube, there is square, so it is what? Mu naught n I to a. So this is what magnetic induction at any point on axis of current loop, hence find at center of current loop. So this is what? Center of current loop. Magnetic induction at center of small circular segment. This is the question. A small circular segment, this is what? Center. A current. Carrying what? Current. This is what? Radius. Like I current in क्या? Circular segment of radius R. O is center as well as observation point. L, small length of segment. magnetic induction at O. Say this angle is alpha. Say this is midpoint. This is direction of current at midpoint. This is theta. Theta always 90. Magnetic induction at O. That is dB. KIDL. DL is here L. Sin theta by what? R square. Biot-Savart Law. Theta 90. So dB KIL by R square. Arc upon radius. This length is small. dB KI R alpha. Arc upon radius, or dB mu naught 4 pi R I into alpha. A wire carrying current bent as shown. Into semi-circular loops. Find magnetic induction at O due to number 1 straight segments at O due to straight segment total induction. This is the question. There is a wire, it is carrying current bent as shown. If these are two semicircular loops, what is magnetic induction? Radius of this is R1, radius of this is R2. This is current, right? Direction of current. First, due to AB due to DE B2 it is 0 as O is on central line. Special case किसका था ये? Biot-Savart Law का on central line B was 0. Second, due to BCD, that is B3, circle mu naught I 2R1 at center of a current loop, and this is half. That is B3 is mu naught I 4R1. Direction, look, this is direction of current at O, out, my fingers out, yeah. Right hand thumb rule. Outside. Due to EFA, that is B3, B4, again half mu naught I, what, 2 R2, mu naught I 4R2, direction, look, out, hands, total B is what? B1, B2, B3, B4. It is 0, it is 0. Mu naught I 4R1, mu naught I 4R2. It is mu naught I common, 4 common. This is what? Magnetic induction. Two current loops. Two coaxial current loops separated by distance 2r and radii are each carrying current I1 and I2 in anti-clockwise direction. Find magnetic induction at midpoint on axis. So this is a question. This is a loop. This is another loop. These are centers. This is midpoint. The distance is 2r. This is r radius. This is r radius. Two current loops separated by distance 2r, carrying current, say this is I1, say this is I2, in anti-clockwise direction. Find magnetic induction. ये इस तरह से है, ये एक्सिस है बीच में, ये करंट लूप है, ये एंटी क्लॉक, यहाँ इसके कारण ये डायरेक्शन होगी B1 की, इसके कारण भी यही होगी. क्या लगाया हमने? राइट हैंड थंब रूल. लुक, ये है करंट लूप, ये डायरेक्शन ऑफ करंट ओनली इधर, इसके भी इधर. नाउ B1 एक्सिस पर देखते हैं क्या था. B म्यू नॉट I a स्क्वेयर टू a स्क्वेयर x स्क्वेयर 3/2 ये था. On axis B1 mu naught I a square रेडियस था ये 2 a square x square क्या था? यहां से यहां तक का डिस्टेंस, इट इज r square 3/2. It is mu naught. The current is not I, it is I1 here. Mu naught I1 R square 2 into 2 3/2. 2r square is there into r cube. B mu naught I1 r square cancels with this r cube. Here left is r 2 root 2 what r. It is mu naught I1 4 it is B1. Similarly, B2 mu naught I2 4 root 2 R. Hence, B, it is B1 plus B2, direction is same. B1 mu naught 4 root 2 R common, it is I1, it is I2. So this is magnetic induction at center of axis to coaxial current loops. Two current loops, axis perpendicular to each other, carrying current I1, I2. Find magnetic induction at point of their intersection as shown. This is one current loop. This is axis. This is another current loop. And this is its axis. The axes are perpendicular and this O is point of intersection. This is current, say I1. The radius is R. This distance says X. This distance is say X as shown. This is current. Due to this, वो फिर लगाया हमने. This is B1 and this is B2. Two current loops, comma, axis perpendicular. This is one axis. ये एक ऐसे है, एक ऐसे है. ये एक्सिस इसकी, ये एक्सिस इसकी perpendicular, carrying current I1, I2. Find magnetic induction at a point of their intersection. O, यहाँ निकालना है. So this will be what? B. B1. This is the formula. mu naught I A square. A was radius, R square to A square R square, X square is here, X square, 3 by 2. B2 mu naught I1 ये था, C2 mu naught I2 R square to R square plus X square 3 by 2. But B is what? B1 square, B2 square, parallelogram law. Mu naught square R square to R square X square 3 by 2. Common out. What is left inside? I1 square, I2 square. So this is what magnetic induction at this point.